The last part of lesson 2.5 starts to introduce the idea of proofs. And in this particular chapter, they're going to talk about paragraph proofs. Later, we're going to learn about two-column proofs, and those are a lot easier. So the last two definitions we want to go over is what it is that we're proving. Theorem is one of the most important words that we talk about in geometry. We've already talked about postulates. Postulates are facts that are already been proven, so you don't have to do anything to prove them. But theorems are not that way, okay? A theorem is a conjecture that must be proven. It's a conclusion that you have drawn, but you don't know if it's true or not, okay? So an example of a theorem is the vertical angles theorem. Vertical angles are congruent. Now, I already mentioned to you the reasoning behind why vertical angles are congruent, because they're sharing a straight angle with the same angle. Therefore, they have to be the same measurement. There's a whole example of a proof involving the vertical angles theorem in your textbook, for example, number 3 on the bottom of page 98. So you could always look at that as an example, okay? Okay, so we're going to talk about a paragraph proof. Now, a paragraph proof, okay, is a paragraph that lists the steps in paragraph form to prove that something is true, okay? Facts and characteristics. You're always given something. A given list shows what you already know, okay? Sometimes you'll be given a diagram to look at. Sometimes you'll also be given an actual statement, okay? You are going to prove the conclusion that they tell you to prove. And they're going to say, prove this. That's the conclusion you're trying to prove. But you're going to get there through a series of steps. And a diagram is often there to give support to what you're looking at. Okay? Now, I didn't fill this in right here, but in your notes, you're going to get to see examples of paragraph proofs, because we can't fit a paragraph proof here. But we're going to do some in just a few minutes. And that is going to be on page 24 of your notes. So you can write in 24. On page 24, when you get your notes next week, it's going to give you the two paragraph proofs that we're going to try. Okay? So we're going to use paragraph proofs in relation to vertical angles, complementary angles, and supplementary angles. So I kind of already showed you these pages, but I want to focus on them a little bit more. Let me see if I can blow that picture up a little bit without making it be too blurry. Let's see. Okay, it's a little bit better. It's a little blurry, but not too bad. Okay, so we are going to be discussing, sorry, I just opened up something I didn't mean to. Sorry. We are going to be discussing these theorems. These are all theorems. None of them are proven. We have to prove everything. Now, in some lessons, they're going to do, in the examples themselves, they're going to do the proofs for you. So you don't have to prove everything. Other ones, you're going to be asked to prove in the practice problems. So we're going to do a couple examples of the ones they might expect you to do in the practice problems. So we're going to basically do a few of the suggested practice problems ourselves. Now, the vertical angles theorem says that vertical angles are congruent. I already showed you the reasoning for that, okay? You don't have to worry about that because it's already done. And you can look at it in your textbook on page 98 in example number 3, okay? The congruent supplements theorem, that's another one that's already in your textbook, okay? If you look on page 99 and you get to, there's an example 4, that's not it, but below it is where it says theorem 2.2, congruent supplements theorem. That's going to give you right below it the proof of it. It just simply says that if two angles are supplements of the same angle, then the two angles are congruent. Okay? So that makes sense. That's kind of like what we were discussing. So if I have, it kind of relates a little bit to vertical angles. Both angle 3 and angle 1 share a straight angle with angle 2. So that means that angle 3 and angle 2 are supplementary, and angle 1 and angle 2 are both supplementary. So angle 1 and angle 3 are supplements of the same angle, okay? So if they're supplements of the same angle, then they're going to be congruent to each other. Now that's looking at it in the actual, to stuck together in an intersection like vertical angles. But this also works if they were listed separately. So this might be another example of congruent supplements theorem, okay? Angle 1, if you were told that angle 1 and angle 2 are supplementary, and you're told that angle 3 and angle 2 are supplementary, and you're asked to then prove that angle 1 is congruent to angle 3, you have to do a little bit of work here in this formula to prove it. Now, you can't just say, well, they're supplementary to the same thing. You have to lead the answer by using, sorry, hold on. You have to lead yourself through using what you know to be true about supplementary angles. So it's going to require some steps here. Okay, I'm not going to go through the whole process because we're going to do some examples in just a minute, but know that you can look at the proof of this second theorem on page 99 in your textbook. Okay, now the other ones, congruent complements theorem, that's one of the ones that we're going to do in our notes. And let's see, right angles theorem. Okay, right angles theorem, all right angles are congruent. That's kind of a duh one. They're not going to prove all of them, but some of them are listed in your in the exercises in the book. Okay, but I'm not doing every single one of them. Okay, so if you wanted to actually see the right angles theorem in action and being able to see what that one looks like, then you could look at, I'm trying to see, you could look at example number 31. Oops. Example number 31 in the suggested practice problems, okay? So you could do it, or if you were stuck and you couldn't figure out how to fill in the paragraph proof, then you could actually go ahead and look at the answer key online, and you'll be able to see that, okay? I just realized I forgot to upload the answer, so I'll make sure I do that when we're done here. Okay, and then the supplementary right angles theorem says that if two angles are congruent to each other, meaning they have the same measure, and they're supplementary, then each of them has to be a right angle, because if they are supplementary, okay, if one was slightly bigger than the other, they wouldn't be congruent, okay? They have to be congruent to each other. Those would in fact both be right angles because 90 plus 90 is 180. Okay? We're going to do a proof of this one as well. Okay? All right, so I'm gonna pause the video here and do a new video to actually do the proofs that we're going to do on the last page that's going to be in your notes.